Good morning. In the last week, we have discussed the splitting of the d orbitals. The shapes of the d orbitals is different. Out of the five degenerate d orbitals, dxy, dyz, dxz orbitals will present in between the axis, and the dx2y2 and dz2 orbitals are present on the axis. Therefore, there is different orientation, and the degeneracy of the d orbitals is disturbed. That is called as the splitting of d orbitals. Now today we are going to discuss the splitting of d orbitals in octahedral metal complexes. Now, according to the crystal field theory, any metal complex is formed by the attractive force between the metal ion, which is positively charged, and ligand molecules will act as negative point charges. And according to this theory, as there is an approach of the ligand molecules towards the central metal ion, the degeneracy of the d orbitals will get disturbed. Means the orbitals which are T2z set, means dxy, dyz and dxz, and dz2 and dx2y2, which are easy set, will get higher and lower in energy. This higher and lower amount of energy will depends upon the geometry of the metal complex, and the geometry is depends upon the number of ligand molecules surrounded around the metal ion. For example, if four ligand molecules are there, then it will give the two possible geometries. One is a tetrahedral and another is square planar. If the ligand molecules are 6, then it will give the octahedral geometry. So when the ligand molecules are 6 surrounded to the metal ion, it will forms the octahedral complex. Now, in this octahedral complex, how the splitting of d orbitals is taking place. I have given the figures on your WhatsApp group how the octahedral complex is there and how the splitting of d orbitals is taking place. The ligand molecules are at each corners of the octahedron. There are 6 corners of the octahedron, 8 faces are there. So at each corner is occupied by the ligand molecule. And when we place a axis x, y and z in between these corners and the octahedral geometry, the ligand molecules which are near to the axis are x2, y2 and dz2. Means the orbitals containing these orbitals, that is EZ, dx2, y2 and dz2, if the electrons are present in these orbitals, they will get repelled more by the electrons of the metal orbitals. Therefore, the energy of these orbitals gets lifted, increased, and therefore they will go to the upper side of the energy state, higher in energy. And the lobes which are present in between the axes, that is dxy, dyz, dxz, these have minimum repulsion. Therefore, there is a decrease in the energy and present at lower level of hypothetical energy state. Means in octahedral complex, the splitting of d orbitals is as the easy set will get higher in energy and the T2G set will get lower in energy. Means the electron first occupy the T2G orbital and after filling completion of these orbitals it will goes into the easy orbital. Now how much amount of energy is required for this stabilization? The total 10 dq parameter is the energy for the stabilization of the crystal field, or that is called crystal field stabilization energy. Now the negative sign and positive sign are mathematical expression, means decrease in energy and increase in energy. Now there are two figures, one is 4 and one is 6. Means the electron which is entered into T2G orbital will decrease the energy by minus 4 dq. And if the electron will enters into the easy set of orbitals, then the energy is increased by plus 6 dq and total energy is 10 dq. Okay, so in octahedral complex the T2G set is lower in energy and easy set will higher in energy, and electron will be stabilized in lower energy and destabilized in higher energy. Okay, thank you.